introduce our presenters and then we will get started. So today we have Adrian and Eamon that will be taking charge. So Adrian, let me get your deck pulled up and then we can just go ahead and get started.
Sure, thanks, Ashley. Yeah, hello everyone. Thanks for joining today's session. My name is Adrian Gu. I'm a principal member of technical staff here in AT&T Labs. Okay, so let's move on. This is the agenda today. So we'll talk about continuous integration and the continuous deployment, why it is important in our wireless technology. And then we will talk about the automation tools that we use for deployment automation, configuration automation, and also test automation. And I personally mainly focus on working on test automation. So we'll focus a little more about test automation. Okay, so this is the agenda. Let's move on. Yeah, so continuous integration and the continuous deployment, why it is important, right? So continuous integration is, I think it gets started in the software development world, right? So traditionally, when we do, I should say before CI/CD, right? So how we do software development is that, let's say we have 10 developers or more than that working in a software development team. And what they do is they make code commits in a common shared code repository. And then there might be a nightly build kind of thing. So over time it's built, and then the software is then being handed over to the testing team. And then the testing team starts to verify it. And it seems to be working, right? So this is more like the traditional waterfall kind of development flow. But what are the disadvantages over there, right? So it will be like, one is, for the developers, it's actually taking longer for them to know the feedback, for them to know whether the code is working or not, right? And then very often when the testing team finds a bug, it becomes a lot more challenging to find out the root cause, because there are so many code check-ins and we don't necessarily immediately know what was the commit causing the issue, right? And then, so CI/CD is actually going to, is introduced to solve this kind of issue, right? So, and with that, with CI/CD, we have a lot of automation that does the automated this disadvantages that I mentioned will be largely eliminated. Okay, and we as AT&T, of course we do a lot of software development, right? And the CI/CD flow applies here. And at the same time, we as a telecom operator, we also buy a lot of softwares from different vendors. So if you remember a few weeks ago, we talked about 5G core, right? So, and the 5G core network is composed by a lot of network functions. And there are big players in the industry like Ericsson, Nokia, and they all, they are the vendors in this domain and selling those network functions, okay? And then we integrate those network functions together. So if you remember the diagrams that was shared during the previous session, when we talked about 5G core, easily there are more than like 10 network functions and they work together. And then they are integrated together to provide the services, right? And the same thing applies here, even in this use case scenario, that we naturally would have 10 or more teams working on each individual network functions. And when we apply any change we absolutely also want to know the feedback as soon as we can, right? So then the CI/CD process applies here as well. Okay, so so I will dig deeper into the deployment automation, configuration automation, and then test automation. And Jenkins is like the most popular CI tool here, right? We have, and the Jenkins has this feature called pipeline, and it's kind of like we can define workflows. Okay, so it sits on the top of the orchestrator layer, right? So we can use Jenkins to automate the deploy whenever we have some new software available. Can be our own software, can be commercial software, and then after we deploy it, we want to use Jenkins to trigger the configuration work. And then finally, we want to let Jenkins to trigger the automated testing so that we can have a closed loop to know how it works. Okay, so actually let's move on. Okay, so deployment automation. Traditionally, in the wireless technology, like I mentioned, in our network, we have different network functions, right? And it used to be actually, we call it physical network functions, and they are all running on vendor supplied proprietary hardware platforms. And then in about 2012, ETSI, which is the European standard organization, they came out with the initiative called network function virtualization. And that basically enables the network functions to be deployed onto cloud. Okay, and you see two terms here. One is VNF, one is CNF. So VNF is virtualized network function, and it can be deployed onto cloud. Okay, and then in that circumstances, each VNF can be composed by one or multiple number of virtual machines. Okay, and then OpenStack is like a very commonly used cloud software, right? So, and in OpenStack, when we do automated deployments, there is a service called a heat. Okay, and heat can be defined in YAML format. YAML is a markup language, right? Although they claim YAML itself is actually a recursive acronym, right? It's YAML and markup language. But anyway, it's a data serialization language, and we can define YAML files, and then the heat service translates the YAML file into OpenStack APIs and to create the applications and the network functions on the cloud infrastructure. Okay, and then the network continued to evolve, right? So when 5G comes, so 3GPP actually defined the vast majority of the core network elements as service-based architecture. Okay, and with that, those network functions are now called CNF, which stands for containerized network function, and they are going to be running in a Kubernetes environment. It can be a native Kubernetes, can be a Azure Kubernetes, can be anything, can be Red Hat Kubernetes, right? And so in the Kubernetes environment, so there's this tool called kubectl. So that's the command line tool, comes with Kubernetes, and we can use that tool to deploy the containerized applications. Okay, so let's move on. Configuration automation. So once the network functions are deployed, we want to configure that, right? So, and then Ansible is out there. It's a widely used automation solution in configuration automation. It's capable of doing software provisioning, doing the configuration management, and it even supports application deployment. Okay, and using Ansible, it actually defines the playbooks, and it's in YAML format again. Okay, and by the way, I forgot to mention YAML is human readable, right? Kind of like a JSON, so we can easily just read it, and it's not necessarily a developer working on the YAML files, so it can be an IT engineer or system administrator will be capable of doing so. And then Ansible supports inventory so that we can configure massive number of nodes, right? We can execute the playbooks in multiple numbers of nodes. By default, Ansible is agentless, and it uses SSH by default to perform the configuration. Okay, and of course, it can be extended to support other communication methods for configuration. Okay, let's move on. So test automation. And like I said, test automation is the section we will talk in a more detail. So I want to cover the context of our testing. What are the systems under testing? Okay, and then I want to touch base on how we test manually. Okay, and then what are the tools we use for testing? And then at the end, we'll talk about what are the automation tools that are available and how we would be designing an automation system. Okay, so what we see here is a pretty busy diagram. That's how our 4G and 5G network looks like, right? So on the upper left-hand side, that's the EPC, that's the evolved packet core supporting 4G radio, okay? And with 3GPP release 14, we also have this CUPS EPC, and it supports even 5G radio as well. And then on the upper right-hand side, that's what we actually had a session on a few weeks ago. That's 5G core, right? It's defined in 3GPP release 15. And so you see a lot of nodes here, and those are working in a service-based architecture. And these are the containerized network functions that are composing the 5G core network. Okay, and then we have the 4G radio or 5G radio down below. And so that's how we provide 4G and 5G services, right? And when you do internet browsing, this is what mobile broadband is for. And when you do, you make voice call, you send messages, and you are, of course, moving around, right? You can be driving, you can be taking a bus or walking, and a lot of handovers, we call mobility, will take place, okay? And so to put our conversation of test automation in a context, I will use the 5G core as the example, okay? So 5G core will be our system under testing for the conversation. Okay, so actually let's move on. So what are the scenarios we test, right? So we of course need to test our infrastructure as well as the application, right? So infrastructure means in the 5G world, it's going to be our cloud native infrastructure, right? So we test capacity-wise, security-wise, make sure it's highly available, and we do regression tests as well, so that in case we have code updates, upgrades, we run a very quick set of testing, making sure everything still works fine. And then we also do the application testing. Application testing is also basically the CNF or the network testing, right? So we do unit level testing, integration testing, feature and functional testing. We test end-to-end service with real mobiles. We do capacity testing, and we also do regression testing. So these are not necessarily fully inclusive, but these are the scenarios we test, the main scenarios we cover in the testing. Okay, let's move on. And how we test manually, right? So let's understand, before we talk about automation, let's understand how we test manually first. So in the manual testing, we can either use a real handset or we can use a simulated tool, okay? And in both pictures, so the yellow icons stand for the tools, and the blue icons are the systems under testing. So when we use a real handset, right? A real handset can be a smartphone, can be an tablet, can be an IoT device. Then of course, it's going to talk to the real network, okay? And then the real network is actually, in this case, bigger than 5G core itself. We have the radio access network. We also have the internet. We also have the MS core. So MS core network, just to mention, is when we make voice calls, video calls, when we do messaging, the call goes to MS core network as well. Okay, and that's the manual. That's when we test with real handsets manually, and we also test with simulation tool solutions. And why we need that? Okay, so reason is one is it's not practical, of course, that when we are doing the capacity type of tests, right? So it's not practical to use a real phone. Let's say I have a network function that is supporting 1 million subscribers. Then of course, there's no way we can test with all real devices, right? That's how the simulation tools come to the picture. And also those phones, if we test with real handsets, those phones are made to comply with the 3GPP standards. And sometimes we cannot create some negative scenarios, right? But with the simulation tool, we have a lot of flexibility that we can even test with negative scenarios. We can hack these messages, right? To make sure our network is robust enough to handle those negative scenarios. Okay, so when we test manually, again, we can either use a real handset or we can use a simulation tool for different types of testing scenarios. Okay, let's move on. Yeah, and so this is when we power on a 5G phone, for example, and how the 5G phone connects to our system under testing, connects to the 5G core. Okay, so the solid lines are the control plane signaling, and the dotted line is the user plane traffic. And what do they mean? So for the solid line control plane signaling, it's basically the phone is reaching out to the 5G core network. I want to get myself registered, and then I want to create a PDU session, okay? And upon the establishment of a PDU session, then our 5G core will be allocating an IP address to the phone, and then the phone can start to send uplink or downlink data, right? So just use a real example is that you might want to open your Chrome browser on your phone to visit google.com, right? So the phone then will be, first of all, it's sending a DNS query to the 5G core network to resolve the destination. And then it's going to create a TCP session towards google.com, and it starts to have the HTTP flow, right? And uplink means the data flow is from the phone to the network. Downlink is the opposite direction. Okay, and if we use tools like TCP dump or Wireshark to capture these signaling messages or the user plane messages, we will see how the protocol stack looks like, okay? And so on the control plane, the protocol stack is like, we have layer 1, layer 2. Layer 2 will be Ethernet. And then we have IP layer. We have SCTP at the transport layer. And then we have NGAP. NGAP is the protocol from the RAN network, which is G node B to the 5G core, okay? And we also have this NAS layer sitting on the top. So NAS is non-access state stratum layer. That's basically the communication from the UE, from the phone to the 5G core, and NGAP is relaying that this message. And then on the user plane, and this is how the protocol looks like. So we again have layer 1, layer 2, we have IP, and then we have UDP, and then we have a GTPU layer. So GTPU is basically an encapsulation layer, okay? And then we, again, on top of GTPU, you see IP. And this IP here is the UE to internet server IP layer. Okay, so the IP address here down below belongs to the infrastructure, belongs to the G node B and our 5G core. And then the IP layer here belongs to the phone and the internet. And there's a reason I want to, talk about those protocol stacks, is that if we look at Linux, okay, so Linux supports SCTP, okay, so everything below is supported. And then Linux also supports GTPU, okay? So this gives us a lot of opportunity to do a lot of development on our own to mimic the protocol stacks, okay? So let's move on. Okay, and we talked about we may be testing using a real handset, and we might be testing with a simulation tool, right? And when we test a real handset, just take an example, right? We can be testing to make a phone call, right? I open the dialer, dial a number, and press on call button. I can also be testing a Facebook application. I open my Facebook app on the phone and I post something and share it, okay? And so in this domain, so we have automation tools that are available that can automate the process, right? To make the work a lot more efficient. And Appium is the open source automation framework for those kind of testing scenarios that I mentioned. And Appium supports to automate Android phone as well as Apple iPhone, okay? And when it's automating Android phone, Android apps, it's actually going to talk to the UI automator coming with Android operating system. And then when it's automating those apps on iPhone, it's going to talk to this Xcode UI test that is coming from iOS. And Appium is supporting many different languages. So we can use Python, we can use Java, we can use Ruby to do the Appium development. Okay, let's move on. And then simulation tool, okay. So we have many commercial tools out there. Okay, so in this domain, like VRV, Keysight, X4, Sparent, many of those, if you Google, you will get it. So there is a very long list. And at the same time, so we also have a lot of options that based upon open source, we can do our own developments, okay? So I mentioned the Linux, the power of Linux, right? So if you look at the layers of those protocol stacks, Linux is actually capable of supporting many of them already. And then we have these open source projects like Free5GC. Open 5GS, Open Air interface, and many of those. If you just Google those, you will get to see the official websites of these solutions, right? And just taking the control plane protocol stack as an example. So Linux supports up to SCTP, right? And then we can use any of these open source solutions, trying to find a solution that is working on NGAP and the NAS layer. Then we can make our own simulation tool. Okay, so let's move on. And this is about how we design automation. Okay, so so in the middle, I put as test automation platform here. So very often it's like a web application, and then behind the hood we have a lot of scripting. Okay, so not necessarily, of course, you have to follow this architecture, right? But this is actually one direction. And the web application, there are many open source solutions out there, right? You can use Django, you can use mean stack, Node.js, many solutions out there, and those can be used to write the front end as well as the business logics. Okay, and then we also have the automation scripting. So Robot Framework is a very popular framework out there. It has some libraries we can utilize, and we can also, of course, use Python and any other languages to do the scripting. And the automation in 5G core, right? So how do we do the automation? And is that we need to interact with a tool first, right? So we either it's a real handset based tool or it's a simulation tool, and we interact with the tool to make the phone call for us or to run the Facebook app for us, or those type of scenarios. And the automation platform also needs to interact with the system and the testing, right? So when we are running the testing, we might want to capture some outputs from the system, from the containerized network functions, running some commands, take some traces, and so on and so forth. And sometimes we might even want to change some configuration to do some testing. And we also need to interact with probe, see probe as like a giant Wireshark that is, capturing all of the traffic that is traversing through the 5G core network, so that we can inspect everything is working as per the 3GPP spec and it's working fine. Okay, and then a test automation platform needs to be accessible, of course, by the testers, and it should also be accessible by a machine, right? So Jenkins, we talked initially, which is a CI/CD tool in this case, can be interacting with the test automation platform using API, right? So I can have a plugin in Jenkins that is capable of sending HTTP requests or any REST API requests, and then we can hook the test automation platform into the continuous integration pipeline. Okay, the CI/CD pipeline. Let's move on. And then the automation platform, right? What will be the key capabilities for an automation platform? So I put a few items here. One is this an inventory, right? So we need to define the inventory of the systems and the testing, right? Because a network is composed of huge amounts of containerized network functions, right? So it's a very big infrastructure, and our inventory can host all of the data so that I can freely specify which systems and the testing I want to run the test against. Resource management. Resource management means like the tools we mentioned, right, in the automation testing context is one type of resource. It can be the real handset-based tools, can be a simulation tool. And we need to manage these resources, and the automation platform should be able to allocate the resources to the test executions, right? Okay, test execution. So this is eventually we start to execute the tests, right? And while we execute the tests, like we mentioned in the previous page, it will be interacting with the tool, it will be interacting with the systems and the testing, and it will also be interacting with the probe. And ideally, the solution should be designed in such a way that I can just click on a play button with hundreds of test cases, and the automation platform will be orchestrating the execution, and upon the availability of the resources, it executes the testing, right, and it returns the result. And the last portion will be the reporting, right, so that eventually we get to see the result. If I execute 1,000 cases or 100 cases, I want to have a report telling me what are the eventual results. Okay, so that's basically what I put together. I hope it's useful, and we're open to Q&A session.
Hey, Adrian, that was actually awesome. Great job. There's actually a couple of questions. Some are really interesting, but I'll touch on one question. There's Tadele Lama that was asking the type of product or configuration automation tool or that we're using based on Ansible. We can't really touch on that. What I can say is Ansible or Chef or Puppet are heavily used. I certainly advise you that if you are interested in working in the IT domain, to either become knowledgeable with Ansible or Chef or Puppet. They're heavily used, heavily helpful. For example, with Ansible, in one command, you can update, for example, 1,000 servers, right? So you can load packages and change configuration and so on fairly easily. So Chef, Puppet, Ansible, certainly advise you to learn. It is good to have on your resume. It's great knowledge to have. And if you want to have a career in the IT field, play with it. It's relatively simple, so it's great. So one question that I want to address is Abhishek question, and it's regarding the SBA and how it benefits core network signaling and latency and so on. So service-based architecture, the key component is actually it enables or it utilizes cloud. And once you utilize cloud, then you have the ability to take gain out of, for example, SDN, or software-defined network. Your ability to have function running or being collocated in the same hardware or in the same center drastically reduce latency. Now, your ability to also turn on and off resources as you wish, right, and bring them in different proximity level based on the latency budget that you have, also allow you to, in a way, control the latency and reduce the latency. So the key component that we want you to take care from that, and it's a little bit throughout the past presentation as well. 5G, cloud computing enable 5G, right? So the knowledge of cloud computing is extremely critical if you want to work in the 5G field. Why? Because the advantage of cloud computing allow you to move function closer to the network or to the edge, and you can divide those functions in multiple functions. It's kind of like a little bit what 3GPP SBA is doing. And by doing that, you in essence reduce the latency, right? Because you can have services running pretty much anywhere you want. And that's how you play with the latency.
Yeah, I have a question here from VJ. The question is, which specific language do you prefer most and why? So in our automation, we actually use a couple of languages. Actually, when we design automation platform, we want the platform to be extendable enough to support different languages. Can be Python, can be Golang, right? So it just want the platform to be very extensible and very flexible. Okay, what we use most is actually Python for the time being, because we have so many libraries that we can benefit from. I hope that answers the question.
Well, I'm going to add a little bit more on Vijay's question, because actually it's a very interesting question and one that really truly gives us opportunity to maybe coach you in that regard. One of the things that I certainly advise anyone who wants to be a developer is to understand the intrinsic qualities of a given programming language. Sorry. Right? Python is good for certain things. Java is good for certain things. C++ is good for certain things. So each language has its quality. Right? If you are a good coder or a good programmer, right, and you know one language and you know it very well, that knowledge of one language you should be able to apply to another language, right? So that each language will have its intrinsic capability, capacity, and limitation, right? So we want you to understand that, right? So the programmer that have an advantage on other programmers, right? So if you want to distinguish yourself in the industry, if you're able to know when to use a given language and why that given language is better than another language for a particular problem to solve, then you're going to be considered a fantastic programmer.
Okay, thanks, Eamon. There's a question from Nathan about in the user stack mentioning how does UDP and the GTPU layer operate without an IP layer. I think what I did is I put UDP/IP, and that must have confused you. Yes, the UDP GTPU runs on top of UDP, and then UDP on top of IP. And then on top of GTPU, you see again another IP layer, right? So basically, think this as like a layered structure. So the IP on the top belongs to the UE and the internet. And then GTP is basically providing a tunnel between the phone and the network. So this is doing the encapsulation. Okay, so for GTPU to work itself runs on top of UDP and another layer of IP. Okay, so there's IP on the top, and then there's also another layer of IP in the bottom.
So there's two questions actually regarding Wireshark, one by Ivan and one by Mushart. So I think there's an interest toward Wireshark, and I'll try to bring a little bit Wireshark is. So you can download Wireshark. Right? You can install it on your PC, and I'll give you an example if you want to use Wireshark. Right? So for example, you may want to test the security capability of different voice over IP application, right? Or maybe, I don't know, if you have Facebook Messenger, or if you're using WhatsApp or otherwise. So what Wireshark does, in essence, it look at all the packets that are going through an interface. So you're listening to the packets on a given interface. So you basically have the ability to go through your TCP stack and see, all right, this my machine, for example, I have application XYZ that are trying to reach another end, and so on. So with Wireshark, you have the ability to trace what your application or function is doing. So then you can see the communication flow. So you can go through what we would call a call flow. It's really good. I certainly invite you to install it. Then you can just browse the internet and see what happened, right? What packets are exchanged between you and in Gmail, for example, your Gmail account or your Hotmail account. Maybe you do a video conferencing with your family using Messenger, and then you can see what type of packet exchange, and so on. But if you want to go deeper a little bit, just with Wireshark, you have the ability to find, for example, security issue. You might be seeing messages that are not encrypted, maybe messages that are encrypted, and you're going to be able to ask yourself and question yourself a little bit. So it is, I mean, it's free to download. You can install it. It's great to use. Great troubleshooting tool, right? They're absolutely fantastic. And from an educational perspective, I invite you to go through just to kind of go through the flows for basic network communication, basic application.
Okay. I'll take the next question from Sonia. What is the difference between 4G and 5G? And also, do you see future generation for cellular networks being developed in the next years? Okay, so 4G, I think roughly started in 2010, right? And now 10 years later, we are deploying 5G, and then 6G might be another 10 years later. So the difference between 4G and 5G, right? So 4G is a great enhancement on top of 3G, because 4G really improved the throughput, right? So the theoretical highest throughput can be 1 gig BPS. And from a use case scenario perspective, 4G basically enabled mobile broadband, right? So eMBB, enhanced mobile broadband. And then what's the difference with 5G? Okay, with 5G, one is we have even higher throughput. The theoretical throughput will be 10 gig BPS. And then also another advantage of 5G is that we will have a lot higher efficiency in utilizing the radio spectrum. Okay, so in the same radio bearer, it can carry 10 times more of data. Okay, so it's more efficient usage of the radio spectrum. And also 5G enables more use cases. So besides mobile broadband, it enables this massive IoT. So we can connect to massive number of devices, right? The future network is not only about smartphones, it's also about connecting all of the devices, right? And then it's also having another use case. We call it URLLC, which stands for ultra reliable, low latency communication. And that's for like remote medical, virtual reality, self-driving cars. So it's enabling a lot more use cases. Okay.
Yeah, that's a fantastic answer. If I may add, for 5G, I really want everyone to kind of have the word latency in mind, right? So 5G really tackled the latency problem. And if you guys recall, Vikram, in his presentation, he had kind of a description of what first generation, second generation, third generation, fourth generation, 5 generations architectures are. And in essence, they each target a problem. Right, so the first generation, it is about connectivity, right? So it's about the capability to make a call. Second generation, it's about the capability to make a call, but also to add services on top of that, right? So the SMS, maybe sending email, right? So the BlackBerry, will not work on the first G network, but would work on the second G network. Third G was about bringing data into it, right? So now the capability to browse the internet, right? Look at basic videos. 4G, now you want like tons of bandwidth, right? Now your device is really just a computer that is mobile and moving anywhere. On 5G, you bring a lot of efficiency, as Adrian said, but one of the key components of the 5G infrastructure is to reduce the latency. And this is to enable the real-time application. And a lot of them are going to be B2C type of application. I'll briefly touch on Musharat Chaudhary question. And Musharat's question is toward 5G and certification and so on. And do I need the master degree and the major on computer engineering? The key component here is it really depends what do you want to work on, right? So you can work on the radio side. And next week we're going to have a session by Ahmad Mansour on the radio side, so the radio access network, and there's plenty of work on the radio side, right? So now you're talking about how to transfer a signal in the air interface, and how does that signal is sent using the smallest bandwidth possible, for example, right? How to use some of the co-localization on the radio side. So you can work on the radio side, and then you might be looking at becoming a KPI engineer. So understanding how to modelize a radio environment, you can certainly study in that, or go through internship and so on that one. And you would work on 5G, but you will be specializing on the radio side of the house. You can be looking at performance and so on. Then obviously a mobility network is something that is extremely huge, right? So if you want to work in 5G, you can be working maybe on devices that do quality of service, maybe on devices that are on networking side of the house. So it depends what excites you, right? So look more of 5G as something that requires a lot of competencies, and the competency that you want is the one that you should be working on. And so you can be a network guy and working on 5G. You can be a radio guy working on 5G. You can be a developer and really just building 5G application, leveraging the 5G network. And you can be an architect working in 5G. So before you look at master degrees that you are interested in, so on, because it's super vast, right? So choose something that you like, and then you can apply that in 5G. There are core competencies that 5G require, and work on those core competencies regardless where you want to work. Right? So you want to be you want to have the knowledge on cloud computing, you want to have programming knowledge, and you want to have networking knowledge, and a little bit of database knowledge as well. So if you have all those knowledge, you'll find your way.
Thanks, Eamon. There is a question from Jeremy. Are the containerizations, virtualizations spun up on servers to run specific automations? Yes. So remember we talked about virtual network functions. We talked about containerized network functions, right? So if you Google data center, so you will see pictures like, you know, huge racks of computers and they are connected together, data centers, right? And same thing is here, right? So we have these data centers, and they're running OpenStack, or they're running Kubernetes, right? So they're our cloud infrastructure, and then these applications can be the network functions are running on top of the infrastructure in the form applications, can be virtualized, they can be containerized. And then automation is also those add-on applications running on the same infrastructure, so that we can do the automated deployments, configurations, and tests like we talked about.
All right. I'm going to touch on Mehul's question. So Mehul has a question regarding the open source platforms and so on. So we understand there's tons of open source platform, but the beauty about open source platform is that there is tons of open source platform. So it is difficult to really tell you which one is better or not, because it's a little bit like programming language in essence, right? So you might be comparing different things and looking what is better for your particular use case. What I can certainly advise is when you go into your career, you're going to have to compare different open source platforms and also proprietary platform. Right? So if you have the capability to critically think on what capability and what are the limitations and really the cost of an open source platform, right? So the cost of ownership, right, and the cost of support versus a proprietary software, or versus another open source platform. So if you have the ability to do those comparisons, you'll have certainly a gain by that. So that's one way I would like to answer your question. There's not a best one, there's not a worst one, there's just many tools, and some of the tools will be better for you on certain applications. But you have to be able to critically think on what it does and not. Now, the advantage of open source platform is as someone who's a student, for example, or new in the career, the open source platform give you the ability to learn skills on the fly at really a very limited cost. So that's a key component that you certainly can leverage, and you can look. There's a lot of statistics that you look in Google, which open source is the mostly used and how many downloads and so on, and you can look at trends and look, maybe there's something that is more interesting for you.
Thanks, Eamon. There's a question from Musharat. Do we need to know Linux commands to learn 5G? Absolutely, yes. Linux is right now really the core competence we have to understand, right? So it's really so important to dig into Linux, and we need to know, of course, the basic commands to operate. Ideally, we should know some scripting, right, which can make our life a lot easier, right? So, and nowadays, it's so informations are everywhere for us to learn, right? So even on your personal computer, just install VirtualBox and then create a virtual machine on your personal computer, right? So you can install Ubuntu or CentOS or Fedora, Linux over there. And Google is our best teacher, right? So there are so many online courses, and that can help us to learn. And you can do hands-on with Linux, right, in your local personal computer. So I do encourage that. Yes, that's core competence. and whatever you do, even if you are, regardless, you want to be a system administrator, or you want to be a developer, or you want to be a tester, it's everywhere Linux will be required. So yes, that's important.
Yeah, if I may add something, actually, there's not a question necessarily on that, but really the work that Adrian is presenting and the work that Adrian and his teams are working on is something that is extremely important because it enables you to experiment. Right? So when you have a CI pipeline and when you have automation tools and when you're able to gather data and look at KPIs on the fly, it gives you the ability to experiment. So in a really quick manner, you can identify whether something has a positive or negative impact to the network. So the skills that were presented today are extremely critical, because once you have that, you can build an architecture that allow you to experiment, and the experiment changes. All of that you can do in the mobility world, but you can also do in other world, right? So I just wanted to say, like, it is extremely critical, and hopefully you can take that with you, right? So it is important to have that automation pipeline because it gave you the ability to experiment.
Mm-hmm. Yeah. And there's a question from Mushrat about, is there any open source simulator or courses to learn 5G? Yeah, so to learn 5G, right? One is the 3GPP specs. There are, 3GPP defines thousands and thousands of specs, right? So don't get lost. To learn 5G, really just start with one spec first. If you Google 3GPP 23.501, so that is the main spec of 5G, talking about the network architecture. So start from there. And then once you understand this a little bit, then go on with 502, and where it's going to talk about the call flows, the procedures. Okay. And that's one information available. And like any software, so the 3GPP specs are also versioned. Okay. So remember in the slides, we talked about release 15. So you should, if you want to refer to the release 15 spec, so the document version starts also with like version 15.9.0, something like that. So just want to mention that. And I kind of mentioned these few open source components like free 5GC, open 5GS, for example, like free 5GC. Okay, so just Google it, go to the website, and you can actually install it even in your local environment by creating virtual machines using VirtualBox. And for those open source projects, right? So free 5GC is meant to provide an open source 5G core solution, but they need to test their solution as well, right? So they need to write some testing capabilities to test the open source 5GC. So if you follow these websites, and you will see after the installation, they have testing capabilities as well. And now you can run a simplified 5G core on your local computer, okay? And then those questions about Wireshark, right? So you can, when you are running these 5G cores, you can use Wireshark to take the PCAP, and then you will get to see exactly what's going on in the communication, right? So how the control plane works layer by layer. Okay, I hope that's helpful.
Yeah, so we have 4 more minutes, but I think we don't have any other question really. So hopefully this was really great. Next week we're going to have a run question. Anything you want to add, Chelsea or Ashley?
Hey, yeah, I can close us out. So definitely want to say thank you to both of you for being such amazing presenters and just being so knowledgeable and sharing that with all of us. I know the students really, really appreciate it. So super big thank you to both of you, and super big thank you to all the students tuning in on this Friday afternoon. I'm really glad that you could be here with all of us. And so once we end this session, you should be directed to a survey if you don't mind filling that out, so we can continue to improve and make better virtual events for y'all in the future. And then also, if you need to watch this recording, you want to reference back to anything, that will be available on our YouTube playlist, so be sure to check that out. And in closing, I know we kind of teased it. Next week, we'll be talking about radio access networks. I know there are a few people that are really excited about this, so it should be a great session. We'll be exploring concepts behind call establishment, RAN architecture, and AT&T's mobility network front door. So should be good. But with that, everyone enjoy your weekend, and we'll see you next time.
Thanks.